Okay, so let's do the practice problems for lesson 8 here. Um, Number 1 says a man traveling at 35 meters per second increases to 85 meters per second over 5 minutes. What was the distance traveled over that time interval? So I'm going to write down what I know. So I'm going to say um, V. I like VI better. I'm just used to it. V1's fine though. VI is equal to 35 meters per second. VF is equal to 85 meters per second. Time is equal to 5 minutes. I don't really like minutes though, because these are in seconds or meters per second. So I'm going to want to change that to seconds. It's going to be the easiest way. Get my answers in meters. And then you can see my answers in kilometers there, but it's easy to change to that after. So I'm going to change this to seconds by multiplying by 60. Really, that's 60 seconds per minute. So minutes cancel, and I end up with 5 times 60, which is 300 seconds. Okay. And I'm just going to write this down here. 300 seconds. And we were looking for D. Oop. All right, so like I was saying before, in this, there's the one thing that doesn't even show up of the things we've been dealing with is acceleration. So I'll look at my formula sheet and say, okay, which of these formulas doesn't even have acceleration in it? This one does. That one does. This one doesn't. That must be the one that we're looking for. So I'm going to choose that one. So we're going to say D is equal to VF plus VI over 2 times T. And this one is really just straight up putting your numbers into the equation. So if we do that, I'm just going to pause it and put the numbers in here. And I get for an answer, D is equal to 18,000 meters. Even though our answer said 18 kilometers, right? But that's right, because there are 1,000 meters in a kilometer, so this is equal to 18 kilometers. And the question didn't give us any kind of sense of what like direction that we might be going, so our answer doesn't either. So it's not positive or negative or east or north or anything like that. Okay. Okay, number 2 says an object traveling at 100 meters per second accelerates at negative 5 meters per second squared for 15 seconds. What was the distance traveled by the object as it slowed down over the 15 seconds? Okay, so let's write down what we got. We got VI is going to be equal to 100 meters per second. We've got VF. Actually, we don't have VF. We don't have it and we don't care about it. So VF, maybe I'll just leave it. Acceleration is going to be negative 5 meters per second squared. Time is going to be 15 seconds, and distance is what we're looking for. So now choosing a formula, I'm going to look back to my formula sheet and say, okay, which of these equations doesn't even have VF in it, because VF's the one I didn't even care about. And that's going to be our first one here, so that one right there. So I'm going to say distance is equal to VIT plus 1/2 AT squared. Okay, so really now all we're doing is just plugging stuff in. So we know, so we're going to say what was the distance traveled? D is going to be equal to 100 meters per second times time of 15 seconds plus 1/2. Acceleration was negative 5 meters per second squared. And our time was 15 again. And don't forget to square it. So if you do that, you get 937.5 meters. And technically, since I look back at my question, I've got my lowest number of sig digs is 2. That one has 2 and that one both has 2. So my answer should be with 2. So remember, with scientific notation, this should really read 9.4, rounded that 3 up to a 4 with a 7 behind it, times 10 to the 2 meters. All right, number 3. Okay, so 3, an object traveling at an unknown speed accelerates at 4 meters per second squared for 25 seconds. If the object travels 1,500 meters over the time interval, what was the initial velocity? So I'm going to write down what we know here. VI is the one we're looking for. VF doesn't come up at all. There's no mention of a final velocity. Acceleration is going to be 4 meters per second squared. Time is 25 seconds. And distance is 1,500 meters. So again, I'm going to look and say, okay, which of these doesn't even have VF in it? It's the same one as last question. It's that one there. So I'm going to go D is equal to VIT plus 1/2 AT squared. But now I got to rearrange this thing so I can solve for VI, because that's what we're looking for, right? So what I'm going to do is I'm going to take this entire term here and I'm going to move it to the left side of the equation. And I can do that just by subtracting the whole term. So I'm going to go minus 1/2 AT squared. So that's going to turn into 0 on this side. And then minus 1/2 AT squared. So we've got left, I've got D minus 1/2 AT squared is equal to VI times T. So then the last thing I need to do is just divide both sides by T. So divide by T, divide by T. And what I have left is, maybe I'll just put an arrow to show it. I'm just moving up here now. I'm going to write D, not equals, D minus 1/2 AT squared over T is equal to VI. Now, you might be tempted to say that, okay, I've got a T on the top and a T on the bottom. I could just like cancel those or something. You can't. That's a common misconception. And the only reason you can't is because if I've got 2 terms up top, T would have to be in both those terms. It would have to be, yeah, D times T or something like that, right? So you can't just cancel it. But now all we're going to do is just plug in the numbers that we have from our question. I'm just going to pause it and do that. Now I'm going to show you just probably how I would put that in my calculator to make sure that I didn't make any mistakes. I would probably just do the entire top and then just divide whatever that is by 25. So I'd write it like this. So you can't really maybe see like the multiplying symbols very well in this, but I went 1,500 minus and then started the bracket, and I went 0.5 instead of 1/2, and then times 4, and then times 25 squared, and that squared is just applying to that 25, so we're good. And I put that all in brackets so that we know that it's going to be 1,500 minus all of this stuff, because that's what we want, right? And then I'm going to push equals 250, and then I'm just going to go divided by 25 for my final one. Just now doing it that way, just now I know everything up top is going to be divided by the bottom. There's no chance of the calculator kind of thinking I meant something I didn't. And that equals 10. So our answer here is going to be 10 meters per second. And it was positive, so positive 10 meters per second. Okay, number 4. Oh, and then circle your answer. Number 4, a ball is dropped from a height of 3.5 meters into the hand of a person waiting below. The ball comes to rest in the person's hand over a distance of 0.25 meters. What was the acceleration of the ball when it landed in the person's hand? Okay, so for this problem, we're going to split this up into 2 parts. And in physics, it really helps to draw pictures, especially for things like this. So I'm going to draw a picture here of a person dropping a rock down this way, right? And this other person's down here. Actually, I'm going to draw that a little bit different. Let's draw a person. He's a big person. And his hand's going to come out like that. Okay, so part 1 of this problem, we know that the person up here is going to drop it. So we're going to say VI is equal to 0. Then what we're after in the end here, it says what was the acceleration of the ball when it landed in the person's hand. So what happens is that the ball ends up coming, it hits his hand, and then it drops another 0.25 meters, right, before it actually comes to a stop. So we want to know what's the acceleration when it touches that person's hand. All right, so what we're going to do is figure out what we need first is what is the speed that this thing first hits my hand. So for part one of this problem, that's going to be VF, and that's what we're looking for. So VF. Okay, we know that acceleration due to gravity when you drop stuff is equal to negative 9.81. And we also know that his hand is a distance of 3.5 meters from here to there where we drop that thing, right? Actually, that should be up, to where the ball is up there, I guess. Okay, so we know the distance. Okay, so we're going to call this part one. In part one, I look at my info here. So I've got, that's D over there. I've got four things, or that I'm looking for the fourth, I guess. And I don't even have T, right? T isn't even part of this. There's no time in the question or anything else. So I'm going to look over here and say, okay, which of these equations doesn't have time in it? So that's going to be that one, right? The VF squared one. So let's do that. So I'm going to have VF squared is equal to VI squared plus 2AD. Okay, now it's just really the only thing I got to do here now is take the square root of both sides because I don't want VF squared, I want VF. So this is just going to be equal to, or VF is going to be equal to the square root of VI squared plus 2AD. So VF is going to be, VI was 0, right? So 0 squared, which is just 0, plus 2 times negative 9.81 times a distance of 3.5 meters. So VF is going to be equal to, oh, and I made a little mistake. This should be negative 3.5 meters. You know how I caught myself on that? Was because I've got negative 9.8 meters, and I would have went 2 times negative 9.8 times 3.5, and I would have had a negative symbol underneath the square root. That's never going to happen. If you get that, that means you made a mistake. So that was the mistake there, because now I'm going to have a negative times a negative. I'm going to have a positive. So I'm going to get, if you do this here, you get the 68.6, or haven't taken the square root yet, but the square root of 68.67, which is 8.287. And I left a few more decimal places than I would probably want to here, just because I want to leave a string of decimal places until my final answer. So I'm going to leave it as that. That's probably good. I could have left a bunch more if I wanted to, but I'll leave it as that. I think I'll be accurate enough. So it's that meters per second. Okay, so that's part one. That's how fast this thing is going to be going when it hits his hand. Now what we got is like a new problem now. So I'm going to change my color here. It's part two. Now what we're going to have, I'm going to write down what we know for the second part. So this part is dealing with down here. Now, for that, I've got my person. And the ball hits his hand, and it's going to go until it finally stops, like down here, right? VF, the VF that we found there when it hit his hand, for part two now, that's going to be our new VI. Right? So that number I just found, that's going to be 8.287 meters per second. My VF here is going to be what? Well, it's going to be 0, right? Because this thing comes to a stop. So I got that. I also know my distance that it drops there is going to be 0.25 meters. And I'm looking for my acceleration. Okay, so I've got all my stuff labeled here. The only thing that doesn't come up again is is time. So we're going to use the same formula again. So I'm going to start out by writing that down. So it's going to be VF squared is equal to VI squared plus 2AD. But this time I'm looking for acceleration. So if you rearrange for acceleration, you get VF squared minus VI squared all over 2D. So now plugging in my numbers, I get, so VF in this case was 0, right, for this part, for part 2. So 0 squared minus 8.287 meters per second squared, don't forget the squared, divided by 2 times 0.25 meters. So my acceleration here is going to be, and I did it again. Sorry, this is going to be negative 0.25 meters. That's a really common one for people to miss because it's going down, right? It starts up here. My distance was negative, so negative 0.25 meters. Okay, so if you do that, you get 137.34 meters per second squared, and positive, right? So that's kind of weird though, right? Because it's positive. What direction would that be? Even though this thing is moving down, the acceleration of this thing was up. And that makes sense because, like I was saying, like to figure out how the acceleration, the positive and negative makes sense, is it's always going to be pretty much the direction of the force. Like this thing is being like forced up the whole time that this person is like, you know, trying to resist the motion of it going down. So the acceleration of this rock or this ball, I guess, is going to be up the entire time. And finally, my units should be, or my sig digs, I mean, should only have 2 sig digs. So I've got some problems with my sig digs in my problem or my questions. I would like you guys to do them properly. So my sig digs though are going to be only 2 because I've got only 2 in that and only 2 in that. So it's going to be 1.4 times 10 to the 2 meters per second squared. So sorry about the length of the video, but I want to make sure that you guys got a good grasp on this because it's going to be very important. So we've done these rearranging problems before, but I'd like you to do them again because they're going to become really important. And for H and these ones, remember what it means to have 0 for your V1 or your VI. And don't worry about the triangles. I know some students get confused about the arrows and triangles and all that kind of stuff. If it helps, just rewrite this whole thing out as D is equal to V1 times T plus 1/2 AT squared. Like, that might be easier for your brain to kind of to comprehend what's happening without the change in symbols or the arrows and stuff. Do that if you need to, but just know what they mean. If you see that this this just means change in distance, and the little arrow meant displacement, or it's a vector. So we care about direction. Okay, so go ahead and do these problems here. Do all 10 of them for me, please. And I'll see you guys in lesson 9.